Hello, everybody, and welcome to day 2 of Advent of Code in Kotlin. Thank you so much for joining us today on a Saturday. No less. Really excited that you do choose to spend your time with us. If you are in the chat, or if you are tuned in either on YouTube or, as I've been told, also on Twitch, make sure you say hello in the chat. It's always lovely to have you folks. I'm also already curious what you thought about today's challenge if you already solved it. I think it's going to be quite an interesting discussion we'll have today about it, because there's been a lot of very diverse solutions that I've seen. I know that even the way that I approached it, things have changed quite a bit from my first iteration to what I ended up with finally. So yeah, it's going to be very, very interesting. Just like yesterday, and just like the next 10 days, we will have a wonderful guest today as well, who'll bring a different perspective than my own, also to this thing, and it will also give me someone to discuss my solution with, and to discuss their solution with, so that I'm just not sitting here just talking into the void. Before I introduce my guest, though, Maya raises a very good question right up front. Did you remember the hat? Don't worry, folks. It's back. It's back for the dramatic reading portion of this stream, where we'll go through the actual problem statement. So you'll see me don that headwear. Absolutely. Well, we have a couple of folks here saying input processing was very interesting. Copious uses of split. I'm sure we'll discuss about that in a little bit as well. Today's problems was actually easier than part 2. Okay, from last year, from yesterday. So yeah, I think there might be a couple of people here that might agree with you. We'll look at a lot of code today, I think, and there's probably some space for code review. But as I said beforehand, I am not doing this alone. I am joined today by Artyom from the Amper team. Hi, Artyom. Welcome.
Hi there. Hi, Seb, and thanks for having me.
How's your day going so far? I think when we talked beforehand, I heard something about you already enjoying the winter wonderland that is Munich right now.
Oh yeah, like if we have people from Munich, you probably know what Seb means here, because we've got quite some snow. The neighbors from across the street, they said that they didn't see anything like that since 2000, and before 2000 they didn't live here, so they don't know. Yeah, so a shower, it's a friend of yours today, at least here in Munich.
Yeah, I definitely. Actually, we can, through the power of image magic, we can actually pull up a picture from my backyard here. You'll see this is like a drum where like the hose goes. This is a good like 30-40 centimeters of snow. All of this is usually a terrace, but that's not really visible anymore because it's all just snow. So yeah. Well, that's a good time. So do you want to introduce yourself a little bit more than just Artyom from the Amper team?
Sure, of course. So my name is Artyom Khlustunov. I work at JetBrains. And the Amper is the tool we are working now. I will get back to it later a bit. So maybe a few more words about myself. Before I was working on products such as PHP-Storm and Golang, if you know them. Then, and actually, I talked to Seb and said that I have to mention this because otherwise my code will be too lame on the screen. So, like at some point, I switch more to the management, and my assumption is that as like management who codes a little bit, I look better than a developer who writes not that elegant Kotlin code. But anyway,
okay, fair.
Yeah. So nowadays I work on Amper. And I really challenge you to go and check out what it is. Yeah, and I think as soon as Seb gives me another moment, I will maybe say a few more words about that.
Oh yeah, absolutely, and I think we'll dive into Amper just a little bit more into the stream, because I think I have a couple of ideas of how it might also potentially improve all of your advent of code experience, because just like in the previous years, I just actually realized that you have now more flexibility than ever before when it comes to solving advent of code challenges. Because it's not just like you learning the language, for example, for the first time, or like learning a little bit more about the standard library if you're a seasoned developer. But there's so many different facets that you can approach now, right? You can do it in your regular project. You can try out new libraries that help you. You can use things like Kotlin notebooks, for example, for a completely different way of developing things. You have now different IDE choices. You could do it in IntelliJ or Android Studio, but you could also do it in Fleet. And in fact, that's what we're going to do today. So there's just a ton of flexibility. With Kotlin multi-platform, like the things go even further, right? You could maybe build a visualization that runs in the browser or on the desktop, or all these kind of things. There really is a ton of flexibility, and I think Amper adds a little bit of flexibility here as well. So if you haven't read our blog post yet, I do encourage you to do this. Just to give you the short housekeeping cliff notes of all of this, we will have live streams for the first 12 days, and I very much encourage you to join our community on Slack. We're also giving you the chance to win some prizes for this. You don't have to be the fastest, you just have to participate. But what you will have to do is sign up for one of the leaderboards that are mentioned here. If it's your first time in Advent of Code, what you can do is you just go to your Advent of Code page, you go to leaderboards, private leaderboard, and then you put in that one of those codes. The very first one is already full, so you don't need to try that one, but you can try all of the other ones. And there's a ton of resources that help you learn, whether you're a beginner or slightly more advanced. We have previous year solutions. So we, of course, have a Kotlin GitHub template, an Advent of Code and Kotlin GitHub template. We have an algorithms course and a bunch of different things. We will, of course, also be looking at some code using those templates. But if you do want to follow along with the stuff that we're doing today, it's worth pointing out that there is an Amper-based template that you can use if you're feeling slightly adventurous and want to try Amper right away. Whatever you choose, I'm sure it's going to be a great experience for you, and you also get the chance to win some stuff that's Kotlin related, which I think is always super duper exciting. Awesome. So what I would suggest is, because people have been asking about the hat, is that we start with discussing our problem statement that we have here. We'll go through one or two solutions. First yours, then mine. And then I have a couple of things in my back pocket where I think if people will stick around, they'll see Amper in action and how it might make our lives a little bit easier. So make sure, even if you think you already know all the solutions, make sure you stick around. Okay, so with that, we'll do the dramatic reading. I'm not sure if you approach this stuff, Artyom, do you read everything, or are you also the kind of person who just scrolls to wherever the first input is and then tries to like do the shortest path to your solution?
Well, it's a good question. Actually, I really love this story because it's like not only about the challenges themselves. It's like something's happening and there are elves and Santa and stuff. Yeah, it's like I'm always curious, like what's going on and how it's going to end. So yeah, I'm go and read the whole story.
Oh, delightful! I'll have to admit, ever since I'm still riding that high we'll do a quick check back in here in Roman Yelizarov's leaderboard. I am riding that high of being 2 points ahead of him. So at 6 a.m, I don't have time to read all the interesting stories. That I'll save that delight for the evening session. I gotta try to speedrun things. I'm sure that's going to change by about tomorrow, and then I can take a slightly slower approach. Great. we have before we actually dive into this, though, I do want to answer a couple of questions actually out here. Or just one question, which is, why does the Kotlin notebooks need the Python libraries to be enabled? And that's a really interesting question. That's because Kotlin notebooks is a kernel for Jupyter notebooks. So the Jupyter notebooks integration provides you with kind of the general notebooks execution engine, and then on top of that, you can run Kotlin notebooks. Maybe if you keep on tuning in for another couple of days, who knows? There might be a surprise hiding in this area as well. We'll see how it goes. Great. Okay, so without further ado, let's learn about day 2, Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, you will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record the information from each game, your puzzle input. Each game is listed with its ID number, like the 11 in game 11, followed by a semicolon-separated list of subsets of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue. For example, the record of a few games might look like this. You got game 1 with 3 blue, 4 red, 1 green. Oh, sorry, it's 3 blue, 4 red, semicolon, 1 red, 2 green, 6 blue, semicolon, 2 green. And then we have a couple of other ones that follow the same structure. Yeah, in game 1, 3 sets of cubes are revealed from the bag and then put back again. The first set is 3 blue cubes and 4 red cubes. The second set is 1 red cube, 2 green cubes, and 6 blue cubes. And the third set is only 2 green cubes. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. In the example above, games 1, 2, and 5 would have been possible if the bag had been loaded with that configuration. However, game 3 would have been impossible, because at one point the elf showed you 20 red cubes at once. Similarly, game 4 would also have been impossible because the elf showed you 15 blue cubes at once. If you add up the IDs of the games that would have been possible, you get 8. Determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. What is the sum of the IDs of those games? Delightful. So, Artyom, what was your initial thought when you read this statement earlier today?
Before we start digging into the solution, I'd like to share. I don't know is it good or bad, but I kind of feel that like every other solution, I will read in my head with you voice, because it's like just it is now the part of the whole story, and it's there forever.
Oh, delightful!
It is delightful. Speaking of the task, I think that the idea was like the first idea is that like I need to use regular expressions, and like this is the idea. When it pops up in your mind, you're like, no, you shouldn't. But then you're like, sort of trying to trade like, oh, maybe it's like, look, it's like going, it fits very well for this solution. You can try, and then you try, and then you realize that it's getting bigger and bigger, and then probably will spend more time, debugging it and trying to figure out why it doesn't work. And then like, okay, I can use splits. I can use splits and then, loops and stuff. And then like, who uses splits? It's like, it's not that fancy. And it like half an hour passes and then you didn't start yet. No, I'm kidding.
I have to admit, when I first read this, I was like, well, this seems a little annoying. Like this just, I mean, it's a typical day 2 task in the way that, well, of course you need to parse a bunch of input that has a bunch of natural language in it. But I just saw a bunch of I'm like, there's colons in here, there's semicolons in here, there's commas in here, there's different sizes of the individual groups. I'm like, this looks this might be a little trickier than what it lets on. Or just might be a little bit more work. And at least for me, I always keep in the back of my head, I'm like, how do I approach day 1 in a way where I don't shoot myself in the foot for day 2 too much? Because I've done that before. And then if you just need to start over for like the part 2, it's always a little frustrating, I have to say. So I'm trying to anticipate it. And then usually, like at least for the slightly later days, they just completely end up reinterpreting the input in a whole different way that no one could have anticipated. So, yeah.
Yeah, actually, you're absolutely right. My first intuition was that something must be wrong with the order, and I didn't trust it, and it turned out right. So sometimes you really need to look for some tricks inside.
Oh, for sure. Yeah, just like staring a little bit into the actual content. And what I think I could have done, but we'll talk about this in a bit. It's like I could have actually simplified my solution if I had made a couple more assumptions that I just didn't. We'll see how this prediction is going to hold up with split colon and then split semicolon. You already get fairly manageable chunks of text, more suitable for a simple regex. So we'll see if that will come up. We'll see how it goes. Okay, so from here we can switch into our IDE of choice. And keen observers will notice a couple of different things here. First of all, a couple of happy emojis in the chat for dark mode, please. If you're a dark mode enjoyer, we switched that around. And if you all behave, maybe I won't flashbang you in the middle of the stream. We'll see how that goes. And also, you can see that we're in a different IDE today. We are in Fleet, which is our next generation IDE that we're building at JetBrains. You could, of course, also solve this in IntelliJ. There's no problem here. But, we're all about showing off some new and fancy toys. So that's why we're doing it in Fleet today. And, it's a time for learning. Maybe you'll see something new that you haven't seen before. All right, Artyom. So with this, I'm going to follow you. And you can give us a little bit of an overview of your code.
Sure. So, well, first of all, I'm using the template from the, I don't know, Kotlin team, or who actually created this template?
It's an internal, volunteer-run project. It just appeared magically, but actually thanks a lot to Jakob, who maintains this stuff internally for us.
So yeah, actually thanks a lot, because it's fantastic. You just take it and it works, and you don't need to spend time setting things up. And basically I use the same structure. So sometimes it's really hard because you need to figure out how you start. Here everything is already there, so I didn't change much. I just put my code basically there are 2 functions, part 2, part 1, in different order, but anyway. So yeah, basically initially this chunk of code was inside the part 1, but I extracted it to a separate function. So this is basically the transformation from the input to the sort of internal data structure. Basically there is a set, and there is the game that consists of the ID and the collection, list of sets. So it's nothing super fancy. Yeah, and then
a set represents each group of red, green, and blue cubes.
Correct. Yes.
Okay.
So it consists of the number of different cubes.
Yeah.
Yeah, and then in the part 2, I reuse the same parsing, but then do some different computations there. Nothing fancy. And Yeah, what I like this template, it actually has two parts. Like it has the test part, the one that you can copy paste from the solution, and then the real input that you can check against, and it provides with the answer.
So looking at this code, I can see. I think one prediction certainly held true here. There's a bunch of like splitting on delimiters that's going on here, and you have opted. I guess in the internal struggle, the regex did win at the end.
Yeah, sort of. So actually, I had to simplify. So I started with the regex because I'm always curious. Like you can solve like every problem with regular expressions, right?
That is true.
And then at some point, basically, you just stop it. You know that some timeout appears, and that you realize that you already like I don't know have 10 Stack Overflow tabs open, trying to figure out some fancy I don't know look ahead. Well, it was not the case here, but anyway. I had to stop at some point and then decided, okay, I still use the regex because I have some like small simple parts, but then I will rely on split because you don't actually need more for this task, to be honest.
Yeah. So but essentially, I mean, I think this reads quite okay. The only part that I have to admit, or this is kind of also what kept me from going all in with regexes from the beginning, is like the whole group value stuff, and then getting elements. It's just it works fine, but for me, I have a little bit of a hesitation typing this kind of stuff out if I can avoid it. As a result, as you'll see, my solution is much longer than yours actually, and we'll see that in a second. But yeah, the overall thing is really once you've parsed the problem, the actual challenge kind of almost vanishes, right? Like it is pretty trivial, just saying, okay, we'll get all the information of the games, and then we'll look for those games where nothing exceeds any of the elements that we have, and then we'll just sum their IDs, and that's it. Which is, yeah, I mean, there's no real surprises here.
Yeah, absolutely. And actually, this is where I like Kotlin very much, because there are already handy functions like sum of, for instance. So you just go ahead and use them, and you don't need to reinvent something. It just like saves a bit of place, but then it's like super easy to read.
You know what's one of my favorite parts in this is that you didn't make any assumptions about the game ID. Because this one is quite fun, because I actually looked into this afterwards. Like I looked into the puzzle output, and I realized that these are numbered just in ascending order. Like the game IDs are just 1 through 100.
They're just serial, right?
Yeah, exactly. But I only looked at this afterwards, and I did, and even when I looked at it, I was like, I don't trust this. Like, unless I have some code that validates that, like, 57 and 56 isn't switched like somewhere in the middle, I'd rather do it the way that I do it, because any other attempt would be super hard to debug.
Actually, I make the same mistake every time, because this challenge, I always, for some reason, assume that I will need to provide my solution. I know that I don't have to. I only need to provide the result. But it's like, normally you need to provide the solution, and then it's run against some random output, or random input that you don't know. I mean, it's not random, but it's not available to you. And then you cannot make any assumptions, because it will fail for sure. And in this particular case, like really, you already have everything. You can just, run a test, validate it, and then save a lot of time. But yeah.
Yeah. To be fair, I still remember a couple of years ago, or maybe the previous year, there was a challenge where you had 3D cubes that would turn on and off lights that were like overlapping, and you'd have to figure out how many lights were turned on at the very end. And I remember with all, like, I ended up with a solution that had all my test cases pass, like all the test cases that were provided to passing, and then when I used my actual puzzle input, it wouldn't work. I'm sure I wasn't the only one with that. Yeah. So yeah, a couple of nice comments here. It sets the sets none is a great move. So congratulations also here from the community. And to those folks, since I did open the version tab, who are wondering how do I get freed 1.28, either work for JetBrains or wait just a little longer. It'll come out eventually. But I do like living on the edge a little bit, so I'm using the pre-release versions so that I get to live a little, show a couple of bugs in the stuff that's not released yet. Yes. Okay, great. But I mean, this if we go into our main function here, and we will. I mean, I guess we could just run. We'll run both of them just since I don't want to work through too much code. But this will give us a number, right? Your implementations, that's 2162. We can go back here and we'll see that is 2162. Great stuff. And from there, it's usually time to hold your breath and see what kind of freaky things the same input now defines. So the hat goes back on. We'll talk a little bit about that second part. All right. There we go. Just making sure. This hat is not sized for headphone wearers, but it does work, so it's fine. Part 2. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? Again, consider the examples from earlier. In game 1, the game could have been played with as few as 4 red, 2 green, and 6 blue cubes. If any color had even 1 fewer cube, the game would have been impossible. Game 2 could have been played with a minimum of 1 red, 3 green, and 4 blue cubes, and so on. The power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. The power of the minimum set of cubes in game 1 is 48. In games 2 through 5, it was 12, 1560, 630, and 36, respectively. Adding up these 5 powers produces the sum 2286. For each game, find the minimum set of cubes that must have been present. What is the sum of the power of these sets? Okay. How'd you feel about this one, like after having written your first solution? Did you feel like you paint yourself into a corner, or you're like, this should be smooth sailing from here on out?
Yeah, actually, it's exactly like you said, because at the beginning I said like all this parse code was inside the part 1 because I never believed that I will be able to use it. But this time it was like, I can use the same. I just like need to amend it a bit. I think yesterday it was different actually. Even the test data was different. But in this case, I was like, okay, yeah, just use the extract function, and it works super nicely actually. I might sound surprised because I don't work in Kotlin, but it's very nice that it actually creates the function inside the function. It's like the very nice feature of Kotlin, and the refactoring supports this. So it's like kudos to people who are involved in this.
Yeah, and you can see this. You can see this quite nicely here in Fleet actually. So we have these sticky the sticky function header that tells you that parse is actually a local function inside of main. Yeah.
Yeah. So basically, yeah, you just extract the part that's the same, and then like the processing part, I don't know how about you, but for me, like every time I use var in Kotlin instead of val, I really like, I feel that I'm doing something wrong. And it's like, are you sure? Maybe you can avoid it. Maybe you can, do something else. It is so, not thread safe and stuff like that. And then like, again, there is nothing about trading or anything, but then, this feeling. But anyway, I decided to go ahead anyway. So it's super simple. Just run, like loop inside the loop, and it just somehow works. So
very nice. I think one of the slightly, maybe not tricky parts, but the part that makes you think for just a quarter of a second is that the question asks for the minimum number of dice but you end up using the max function, which is, I mean, it's not that really like wrong or unintuitive. It's just the minimum is defined as like the maximum of what you've seen, right? This is kind of the part. But if you're just, if you're still sleeping in the morning, it's like, oh, what's the minimum number? You're like minimum off, and yeah, you kind of run into the wrong direction, and that happens. Yeah. By the way, you're not alone with your assessment of var. Maya also says var makes her itchy, and yeah, var question mark and double bang are
double bang is terrible. Like I cannot sleep after using it. Like.
Yeah, it definitely makes people squirm, it seems like. Yeah, but I mean, with this, if we've already ran this once, but we'll run it again. We also just get a different number, 72,513, and that is the number that is the correct power. Delightful. So we can have.
By the way, can I jump in? Just one more thing, because like I was using it yesterday unintentionally, but today I realized that I am using this approach. So as I found out that I'm using it, I want to share it too. So what I was doing all the time is I was trying to create use the data structure that will be easy to debug. Because I'm super lazy and I don't really want to, wait when it fails, then read the stack trace and stuff like that. So I was using data classes. Like, you don't really need data classes here, but when you put a breakpoint somewhere, like you get this toolbar with all the variables and the stack trace, and then it's like super useful. You basically read the current stack. You can, step over and do all this stuff, and yeah, it helped me a lot. Like, I can hardly imagine how I would do this, like the same task without the debugger.
Yeah, that's actually that's a very, very good point. By the way, Vitlaw also joined in and says they also really don't like the setup of like max lower bound and then min upper bound value to constrain a value to a certain range, but instead using coerce at least and coerce at most. We've seen that one yesterday with Todd, and yeah, these kind of properly named functions oftentimes make the code a little bit easier to reason about. For me, of course, the story was kind of the same. Like, I also just figured, well, we'll parse out all the information, and then from there, we will like the problem just kind of reduces itself. So let's have a little bit of a look, because I chose to do it in a slightly different approach. So for part one, I decided to take this quite literally, to the point where I copy pasted the important line of code right into that part one function. I said, okay, I got 12 available reds, 13 available greens, 14 available blues. So the question that I want to ask, this is a quite literal transliteration of just what the question is, right? I want to know, out of the games, which one is possible given the different types of dice. Now, I parameterized this because I thought, well, maybe they're going to change this around in part two, but then also in the back of my head, I had a little elf saying, that will be way too easy. That's not going to happen. But I thought, maybe they'll do something where you have to loop over each element and see for a huge set of different possibilities. I don't know, do some combinatorial explosion stuff.
Yeah, actually, I did the same, yeah. But then I removed it.
That's perfectly fine. Yeah, of course, we still need to talk about how I even get to that games variable, but yeah, then at the end, it's just the idea of just summing up all that stuff using just sum off, which is, again, very kind of convenient. So where do I get games from? Let's have a look here. Well, games is just taking each line and turning it into a game. That shouldn't be too hard. So there's actually two parts to this. First of all, we have the actual data class game, which is slightly misindented. Not sure what's going on there. But I guess, there we go. Slightly nicer. Which is just the game ID, and then the move set, which in my case is a list of cube sets. Because I will admit, when I looked at your code, for a second I stumbled, because I was like, set as a generic type without anything else. I was like, what's list of set?
Yeah, naming is hard.
It is. But yeah, so I decided I'd just call this cube set. So in a typical fashion, what you're of course allowed to do if you have a function that just builds another function that's essentially just a constructor, that's actually one of the few cases where you're allowed to write functions with uppercase names in Kotlin. So I just have a standalone function called game. This could just be a constructor of the game class, but I decided to extract it out. That just takes a line, returns a game. And in here, we're doing a slightly funkier approach to all of this. First of all, just get rid of the prefix part because no one needs that. And then we'll just grab all the digits, turn it into integers. Because who knows how long those might be. And then I actually looked at this and I was like, there's not really a super nice way to just say, I'd like to drop the string like game a couple of digits, colon. Like essentially what I'm doing down here. There's not really a super nice way because we don't have like remove regex prefix in the standard library. By now, I'm kind of convinced we should. Not that I've ever had to do this in production code, but I still feel like now we obviously need to have it. So I kind of got this together. And I actually, just like you mentioned, I tried to avoid vars anywhere here. Like I tried to make all my stateholder classes or all my data holder classes immutable, and I even tried to make all the variables immutable. Which of course, if you're very performance oriented, means I'm allocating a whole bunch of temporary strings. But that's the price we pay for that kind of code. I did decide though that it was worth kind of implementing some kind of remove regex prefix code. And actually, let me just make sure that I have the variable names correctly. Because thanks to the power of extension functions, this is a two-liner. Like remove regex prefix is a matter of saying, okay, let me find whether this regex matches. If there's no results at all, I can just give you the original string back. Otherwise, if the match happens to be at the very first part of your string, if it starts at the very beginning, then just get rid of the entire range that this match encompasses. Otherwise, if it starts somewhere later in the string, then just return the original string. Is this performant? Probably not. Does it make my code slightly nicer in this case? I would hope so.
Well, it does. It definitely does.
Yeah. So now I can just say get rid of like game, then a bunch of numbers, colon, and the space, and I can just move on. And from there, I can just create my cube sets. So these are all the visible. This is the whole text that describes the visible cube text. I'll split that on the semicolon, and I'll map each of those into cube sets, making sure that I also trim things just to make things a little bit nicer. If I read Todd's message, who joined us yesterday in the Kotlin Lang Slack earlier today correctly, I think this is what may have bit him. Hi, Todd, if you're watching. So creating a cube set, as you may have guessed, is also just a matter of creating a data class with another nice little uppercase function, takes a string, returns a cube set. We'll split on the commas, and then I decided I'd flex my my standard library muscles just a little bit, and I figured we'll use the associate function. So if you don't know what the associate function does, is it essentially turns each element of it allows you to turn each element of your input list into a key value pair that's then part of a map. So in my case, I wanted to have a map of color to count. And I also wanted to do this in a type-safe fashion. So those are kind of the two parts that play into this. First of all, splitting into just like the actual text and like the number and the actual name of the color, that's as easy as just splitting on the space. That's easy enough. For the color, I decided I would define an enum, which is just red, green, blue. I could probably just have used the actual like value off in this case. That would have been perfectly fine, but I decided, well, who knows? Maybe I need to reinterpret this somehow. I'll have a text associated with it with red, green, and blue. this was a great. I remembered that we actually just in I think Kotlin 1.8 something we introduced this new entries property on enums, which replaces the previous values array. This one is supposed to be replaced by entries now, because this is a compiler intrinsic that only generates all the values once instead of allocating every single time, and we'll just grab the first one that matches. And from all of this, we just return a pair. We have the key, which is the color. We have the count, which is the value. Once all of this is run through, we can return our cube set by just looking up the individual parts or the individual cubes based on their color, and we'll put them into the right kind of slot in our data class. I initially, when I approached this, I was like, yeah, we'll just double bang. I don't care. Like, we'll do get value, whatever. And then it explodes because you realize that not all of the inputs define all three colors. So actually here nullability is kind of helping you, like, nudge you in the right direction, because it does force you to provide a different value unless you scream at the compiler. Yeah, and once you have the cube set, you can go back and you can make the actual implementation for the two parts that you need. First of all, is it possible? That's just a simple function of saying, well, if all of them are below the thresholds that we are given, then the game's possible. We'll sum that up. Great. And for part 2, since we're just summing up all the powers, we just need to way to define the power, which is the required reds, as I'd like to call them, which also is just the move set and the maximum of each of the colors multiplied up. So after a lot of parsing and a lot of just being like in the weeds where maybe it didn't even seem like we were solving the problem yet, like at the end, the actual solution, it like decomposes down nicely into just a couple of lines of code.
Actually, I really like how you solve this problem with the required part, because you perfectly avoid using var. And at the same time, the code is super readable. So, yeah.
I will admit, I will let you in on a bit of a behind-the-scenes secret here. This is not the code that I handed in this morning. The code that I handed in this morning is a little funkier. It also doesn't actually use any vars, I believe. So that part's fine. Oh no, it does. It just uses a couple of vars when I do like some of the conversions. There's some shortcuts. But that's not what, I end up with after some refactoring, because that's always also part of the learning experience for me. Quite excited about this. Okay, so there's a couple of things that I really enjoy, and one of them is building visualizations for this kind of stuff. Or well, I like seeing visualizations. I'm not great at building visualizations myself, but I was thinking before we started the stream, I feel like if someone wants to use like Compose, for example, to build their visualizations, Amper might actually make their lives a little bit easier if they want to do that. So I'd really like to just kind of get a basic setup of like Compose going, just to show people like how easy it is to start building visualizations, and then of course we'll omit the creativity part and we'll leave that to the enthusiasts and the people who are out there. But I think to understand even why Amper matters at all in this story, could you maybe tell us a little bit about Amper? And I will also pull up the README here for people who do want to check it out.
Well, I really hope that no one will check what I'm saying right away, because I might be wrong somewhere at some point. But yeah, like the idea behind Amper is that there are quite some people at JetBrains that feel that there are a lot of great build systems around, so you don't really need a new build system on one hand. On the other hand, some things, they are just sometimes too complex, because like obviously if you have a huge project, super like I don't know, tricky pipelines and stuff like that, you use super powerful build systems. That's totally okay. But it kind of feels that not every project is like that, and sometimes you just want to like say do this, and it just does this, and that's it. And you don't have to like learn yet another language how you configure it. You don't really need to know like internal details of how it works, about like it's all that stuff. Again, I'm not saying that like all the existing build systems are bad. It is that perhaps we can do better. Maybe no one tried. Maybe someone tried but didn't succeed, but it's not the reason not to try again. So that's why we decided that, okay, let's run an experiment. So Amper is an experiment. It's not the production-ready solution for sure. And it is just our way to check assumptions. And as we don't want to make it just for ourselves as an internal tooling, that's why we release it and really ask for feedback. And like every time, every release, we are going to open probably some new parts and ask you feedback on them. So the first one, it's very like the part that we really want to hear feedback about is very small. It is the overall design of the configuration. So basically, we have the sort of build files called module YAML. And then the idea is that you just drop a few lines that help you to configure the Kotlin multi-platform project or a JVM project. We don't really limit the build system to like this set of tools, this set of technologies. But again, at this point, like we just want to go like one step at a time, because if we are wrong with our assumption and like we go the whole way and just to realize that there is already something that does it better, it doesn't really make sense. So for now, like and actually if you go to the template for Advent of Code with Kotlin, like there is just one file with just one line.
So if we head over to the template and we head over to use the Amper template, there is this module YAML file down here, and actually as the big reveal, we'll see that indeed we were using Amper all along while we were working on this little project here. And yes, Artyom, do you want to give us an overview of everything that's in this file?
Well, I don't know where to start. So yeah, first I probably want to answer the question why not Kotlin and why YAML, because everyone hates YAML, because you have to hate YAML. Like, why not? You need to hate something. So as I said, at this point, we want to verify our hypothesis about the configuration. So I don't know, for instance, we have settings, and inside settings, I don't know, we have compose and stuff like that. So the question we really want to ask right now, is it like good enough? Is it easy to use? Does it help to like the work on the compose project, or I don't know, serialization? Because like sometimes you just need serialization. That's it. And, is it good enough or not? So the problem is that maybe it's a surprise, maybe not, but like we do have limited resources, so we cannot do like everything at a time. So we decided, okay, first we concentrate on the configuration, but then we need something working. So how do we do that? And we just decided to take the existing format without inventing anything new, which is YAML. That's one thing. The second thing, we decided, okay, for now we use Gradle as a backend because it works, because everyone's more or less familiar with Gradle. And in a simple case like we have now here, you don't really need to interact with Gradle. So in this regard, it shouldn't really diverge us from our goal of getting feedback. But again, as it is an experiment, and if we see the demand, if we see the good feedback, and actually I've already seen a message about like how simple it is, and that's like what we really want to achieve. So it's like sounds very, very good to me.
Yeah, Maya mentioned this a little bit earlier. She says, I added a thing to a project with Amper today, and it was like 3 lines, and boom, I have the things I needed, which is, of course, awesome to hear.
Yeah, absolutely. And I will definitely pass the feedback to the team. So when we see such kind of feedback, if we hear that, okay, like you can improve the design here and there, but overall it's what we need and we could use it, we will continue working, because there are more things that we want to try. I won't really spoil it right now, but we do have something planned for the first quarter of the next year, so stay tuned. We don't stop now for sure.
Oh well, it sounds like you've heard it here first, folks. But I also now I do want to put it to the test now, because as I said, now that we've heard about how apparently it is so easy to set things up. I would like to just see how long it takes us to just get set up with Compose. So I've seen you type this out before, so I'll see if I can just get this back, and we will actually see here that we also get nice autocomplete inside this YAML. So I can go into Compose, and I can just set this to enabled, and I guess that just enables the Compose plugin. Then I guess I'll probably still need my dependencies block, and we'll just take something from Compose desktop. Nice. Current operating system seems more than enough. So I guess we'll set this up, and hopefully, if we've done everything right, I mean, there's not that much space to do things wrong, I suppose. We should just have Compose support now, right?
No, I really hope so.
so let's, yeah, I mean, hey, that's confidence right there. Let's
it's
actually
an experiment, right?
Yeah, that's right. Let's have a look. So if I do application, for example, that's a function that comes from Compose to create a like an entry point. I can do that. Very nice. And then I can create like a window, for example. I'll define an on-close request, which I think is just like exit application by default. It does require you to specify that. And then here is where we could put our composables. So we're not going to like build a visualization out here, but we could just take our part one text, which is a string. We'll probably make sure we import this one from the composables, and we'll do the same thing for the second part. Anyone who's writing Compose is screaming the moment I don't use a column and I have more than one element, so I'll just move that in here. Maybe we'll give it a little bit of styling. What do we have here? We first of all set a modifier. We'll have a modifier fill max size. That seems fine. We'll import the Compose one. We'll also do something like do a little bit of arrangement, because I think we have vertical arrangement. So we'll maybe just center our stuff. We'll do arrangement dot center, and horizontal alignment is an alignment dot center horizontally, and I think that should put things in the middle. It's not going to look very nice unless we actually give it like a font size as well, though. So we'll put like a 40 SP font size on this and do that twice. And let's see.
No, fingers crossed.
And look at that. Just like that, with 3 lines of code and then like 5 lines of Kotlin code, we've managed to take our command line output and turn it into a visual application. That's kind of cool. Obviously, not particularly what I would consider output visualization. We'll professionally leave that part as an exercise to the readers. As always, I do wanna say this again. If you do create any kind of cool visualizations that you would like to see, please make sure that you share them in our Slack community, and we'll happily shout them out. Yesterday, for example, we've also had people asking a little bit about showing off some slightly crazier or slightly stranger solutions to these kind of to the kind of advent of code problems. And I actually found a delightful one just earlier today, just about an hour ago or so, from Jakub Gwodz. I hope I pronounced that last name right. So we can take a brief look at this one, because what Jakub did was he implemented the parsing logic using Kotlin X serialization. Now, Kotlin X serialization, if you're not familiar, is our multi-format reflectionless serialization format that's built at JetBrains by the Kotlin team. It has a bunch of different already built-in formats. Usually, you'd probably use something like JSON or protobuf, but it is flexible. There's nothing tying you to those specific formats. What you can do is you can just provide your own. And what Jakub has done is he's written a serializer that understands the Advent of Code game input format. We can take a look at that in a second. What we do need to do, though, is we need to make sure that the imports resolve. So Artyom, maybe you can just briefly set us up with serialization here.
Do we still need compose?
Oh, I mean, if there's nothing stopping us from keeping it in there, I say why not, right?
Let's have it. Why not? So yeah, I think this should be enough.
Okay, cool. We'll reload the changes for the project. Check on over here, and would you look at that? Yeah, that's all the red lines gone. Now, if you've ever set up Kotlin X serialization beforehand, maybe this makes you breathe a sigh of relief. I know it did for me, because usually Kotlin X serialization, it consists of a couple of parts, right? It consists of a compiler plugin where you have to make sure that the version number is the exact same one as the Kotlin version that you're using. And it also comes with a runtime dependency. And that one has a different versioning format, so you need to make sure that you keep those up to date as well. So it's really nice just for a project like this being able to just say, hey, I want Kotlin serialization, just with JSON support out of the box. Just set that up for me. So that's really delightful. Okay, so we can take a brief look at this. I don't think we'll look too closely into this code. I'll give a quick scroll across this. You'll see there's a lot of very long lines in this one. But you'll see that and it's actually worth noticing that, or worth noting that this is just the parsing part. Again, this doesn't actually solve the problem. This, if you run this code, this only gives you a well-structured output or a well-structured representation of either a single set of dice or cubes, or a whole line, or the entire input, which in this case is just a small sample input. And the way that they did this was they defined a couple of different things here. They first of all defined their function to override string format, which allows the conversions to and from strings via encode to string, and that requires them to override a couple of functions, like decode from string, for which they've defined a bunch of different decoders. They're using experimental serialization APIs here, so there's a couple of yellow underlines here, but that's not going to break anything. They'll figure out which one it is and use the appropriate one. And then they just have different input decoders for all the different parts. And you'll see that while there's a slight bit of boilerplate required here, this allows you to completely plug and play into the Kotlin X serialization library, which I think it's a little crazy doing this for an Advent of Code problem, but it's also really, really cool.
It is cool, actually, and the coolest part that it actually works. I mean, it indeed parses the random input and produces the readable result, and machine readable result, so we can work with it.
Yeah. I love people this is the enterprise version kind of how you would approach this. You would take a battle tested high performance library, and then you use that, and you just make sure that you implement all the correct interfaces and such. So that's quite a cool move. And of course, the fact that at the end, what he ends up doing is just being able to annotate his data classes with serializable, and then being able to decode them like this, even with the generic types, is it's just a cool move. Yeah, Maya also, by the way, says, I think she's kind of seconding my point here. What I like best about the kind of approach that we have here in Amper, where it's just write a couple of lines and get started, is for hobby projects, right? I leave for a few weeks when I get back to fight all the versions again, spend all of my time fixing that rather than coding. Where this kind of stuff gets in the way, that's where things get problematic. So here's there is a question here that maybe you want to answer, which is where are the versions defined then?
Yeah, actually, I was looking at this question. So here we have a fancy way to define the composed desktop dependency, and we call this feature dependency catalog. It's not super original name, you know that. But the problem with this particular one is that it is not fully designed. So I cannot answer right now where it comes from. I mean, like in this particular case, it's just hard-coded somewhere because we wanted to show something, but in the end, we will probably support like existing ways to define dependency catalogs. There is a chance that we will introduce our own if needed. I don't know that. But the overall idea of Amper is that we prefer convention over configuration. So in the best case, everything should work out of the box, as you said, except like the versions, they just match to the Kotlin version. The Kotlin version you can define. But then if you really need to, you can actually use the normal way. So you can specify the dependency like old school way, like the model, the group, like the version, all that stuff. The same about tooling. So there is or there will be a way to define everything, every particular version, but we want that it just works out of the box. So that's the idea.
All right, and I personally think that's a very, very valid approach, because so I've been whenever I start a new project, usually nowadays I go to kmp.jetbrains.com because I'm doing a lot of multi-platform development these days. By the way, if you're a dark mode enjoyer, you'll find that this page has dark mode support, which I just found out. And which of course allows you to kind of set up the whole kind of boilerplate that goes into setting up projects, because especially for multi-platform projects, if you are working on a couple of projects, there is a bit of boilerplate like involved, right? Like it's not just a matter of I'll start in a blank project and like I'll start writing out the configuration from scratch. Having some scaffolding is very, very useful here. So having a configuration format where, but like Amper, where maybe some of this could be condensed, or we could rely on conventions more than having to spell out everything explicitly in configuration. Personally, I would very much welcome that. I have to say, yeah.
Yeah, definitely. Also, Maya mentioned that the plugin will make sure that the versions will match, and actually. There is a big part, and I'm mostly working not on the Amper itself, but on the IDE part. And there are a lot of ideas how we make it work better in the IDE in the tooling. So like working with versions, like realizing what the actual version is used, because dependency resolution can bring crazy stuff sometimes. And I won't spoil again everything, but like this is not just about the build build tool per se, it's about the build tool experience, and the IDE is a big part of it, and we really hope to make it like super useful, super convenient to use. Yes.
And I think for that one, there's an interesting follow-up question that's very much worth answering. Is Amper only good if I'm building in JetBrains software versus, say, on GitHub Actions, for example, where I assume it knows nothing about this YAML file?
Fair enough. So first of all, like at this very moment, it is just normal Gradle. So Amper works as the plugin for Gradle, and then like you can use all the normal Gradle commands to build and run the project. So it will work on pretty much any CI, I believe. In future, of course, we already, again, I'm sort of spoiling things here, but anyway, we already working on our command line interface. So, like, if the CI can be configured, and again, I think pretty much any CI you can like run random command there, so it will definitely work there. So it's not super JetBrains bound. It's not JetBrains bound, and like we don't really want to introduce any vendor lock for sure.
Awesome. Well, I think already the thank you for the clarification is coming in here. Yeah. Awesome. Well, I think we've already seen quite a lot, and we've managed to fill our Advent of Code Kotlin Power Hour quite nicely, because we've seen a bunch of different things. We've seen our different solutions here. I personally, I'm very sorry if I'm just keep on going back to this. If you haven't seen it before, take a look at the associate function. If you're not entirely comfortable yet with the kind of snippet that I've put up here on the screen, maybe have another look. It's very cool. Especially interesting about this one is it has sibling functions. There's also associate by, with, and by to and with to, which the two ones you can forget. That one's not that important. But associate with and associate by, that's you can have that as a little bit of homework, because I believe that those might also come in quite handy in maybe some of the upcoming days. Now, Artyom, you've done Advent of Code before, right?
Yes, I did.
Did you do it in Kotlin?
Yeah. Actually, it's an interesting story. So I wanted to do it in Kotlin. I actually found the project. It's called Advent of Code 2018 on my local disk. And actually, I have two of them. One in the IntelliJ IDEA folder, where I have the like Java Kotlin projects, but it's empty because I started doing the first day because I really wanted to do it in Kotlin. But then someone said like, "But come on, you're working on the Golang IDE. You should do it in Go because it's Go." And I was like, "Yeah, okay, fair point." So yeah, I finished that one. It was super cool, but not with Kotlin that time.
Very nice. So I'm curious if you have any predictions of what something or a type of problem that we might see in the coming days. If you have a suspicion.
Frankly, no idea. I'm scared that I remember in 2018 I had to go and learn about SAT solvers and stuff like that. I really hope that it won't be that challenging, but on the other hand, people want challenge. That's why they're probably here. So we'll see.
Yeah. I think that's a little bit of the beauty of Advent of Code again, is just the fact that there are a lot of challenges of very differing skill levels. So whether you're a beginner and you're just starting to learn Kotlin, or you're you want to refresh yourself and want to sprinkle a little bit of associate somewhere in your code, or whether you want to go super deep and optimize things, for example, write benchmarks for your code, try to find the fastest solution that can process gigabytes of inputs. There's something here for everyone, which is quite delightful. So yeah, with this, here is the slight final flashbang. I do apologize, but our blog does not have a dark mode. But yes, this would be my final shout out before we kind of round up for today, because there will be another stream in less than 24 hours. But until then, of course, your own Advent of Code journey can continue. And the best place to go is to go to the Kotlin Lang Slack and join the Advent of Code channel there, because then you'll find freaky solutions like the one with using Kotlin X serialization straight from the authors, and you can discuss and, I don't know, question them about their motivations, or just congratulate them on really pushing the challenges to new bounds. If you haven't joined any of our leaderboards yet, make sure you do that as well. I'm sure they're filling up rapidly, especially given that you can win some exclusive prizes. I did not mention this beforehand, but I do want to shout it out again. There's a couple of points that you need to fulfill in order to qualify for the prizes. Some parts of this are just, we need to be able to contact you somehow, so make sure you have that information up. And we also need to be able to find your submission, so make sure you tag your GitHub repository appropriately. All the information is in the blog post, so just stop by back there and see if you're already fulfilling all of these things. Wow, wonderful. I have to say, my favorite bit of this whole story today was being able to write 4 lines of code. 3 lines of configuration, 6 lines of code, and then being able to just pop open a window and have a almost visual representation. If I just had a little bit more compose foo right at my hands, we could have added some animations here, but again, exercise for the readers. Looking forward to seeing what we'll see in the next days here. Okay, well, Artyom, thank you so much for coming on. It was an absolute delight having you.
Thanks for inviting me. I enjoyed a lot. I hope everyone else who was watching too.
Awesome. And yeah, if you enjoyed this one, make sure you join again tomorrow and in the coming days. We will have more guests that will all bring, I think, quite different views on the problems, and we'll always have some fun extra things to discuss around the whole Kotlin ecosystem. So make sure you don't miss it. But for now, I just want to say thank you so much for deciding to spend your Saturday with us and being a part of the Kotlin Advent of Code experience. And I hope that we'll see you in one of the future streams. Okay, so take care, everyone, and have fun learning. See you soon. Bye-bye.
Bye-bye.